All right, so let's finish up section 3.1. So yesterday I had some formulas up on the board, and we looked at inverse sine or inverse cosine, inverse tangent. And there are certain times that those trig functions cancel each other out. So we're going to look at basically 6 different formulas. Okay? They're all going to look something like this. So in this case, inverse sine is on the outside. Regular sine is on the inside. And these two things cancel each other out. And the answer that you get back is whatever is right there. Okay, but that only works if x is between certain numbers. Did anybody remember yesterday for inverse sine, the two numbers we said it had to be between?
Negative 90 and 90.
Yeah. Okay, as long as x is between negative 90 and 90, this formula works. Or in radians, negative pi over 2 to pi over 2. Okay, let me show you an example. Right, I'm going to type in inverse sine of 12. I'll just pick a number between negative 90 and 90. Nice. Inverse sine of 12. Okay, when I hit enter, what should I get? Well, what does this tell me I'm going to get? It tells me I'm going to get x. Look where x is on the left-hand side. Ashley? Yeah, we're going to get whatever's right here. Okay, whatever's circled. We're going to get back 12. Okay, so inverse sine and regular sine cancel each other out. So long as you pick a number between negative 90 and 90. Right? So they just cancel each other out. Let's try a number that's not. Okay, let's try like 120. Okay, am I going to get 120 back? No. I get a different answer back. All right, so this formula only works if that number is between negative 90 and positive 90. Okay, so a little bit different. Okay, formula 2b. What's the difference between 2a and 2b? They're almost the same. Yep?
The inverse is inside.
Yeah, the inverse is on the inside, the regular one is on the outside. And this one only works if you pick a number between negative 1 and 1. Okay, let's try it. Let's try 0.5. Let's try the sine of the inverse sine of 0.5. Inverse sine of 0.5. Okay, when I hit enter, what should I get? 0.5. And I do. Okay, but this one's a little different. If I try a number that's not between negative 1 and 1, it's not that I'm going to get a different answer back. The calculator won't even give me an answer. Okay, try typing in like 1.2. Let's try 1.2. Okay, that's not between negative 1 and 1. It says error. All right? So this time, it just doesn't even work. And let me show you what sine looks like again. Let's go like this. Okay, that's what sine looks like. What's the highest that it looks like it goes? 1. And how about the lowest? Negative 1. That's where this 1 and negative 1 is coming from. It's how high and low sine goes. Right? So when I typed in 1.2 and I got an error, I was asking this question. Where does the red line hit the blue curve? Never. All right? If I go above 1, the red line never hits the blue curve. That's why there was no answer to that problem. Okay? It's only going to hit between negative 1 and 1. Anywhere in there. Okay? All right, so the kind of questions you'd see on this are basically like a true-false. Yes or no? Okay, so the first one says, is the inverse sine of the sine of pi over 8, will that equal pi over 8? Okay, is this formula 2a or 2b? It's 2a. The inverse is on the outside, regular is on the inside. Okay. What we might want to do if you can't figure out if pi over 8 is between these numbers, change it to degrees. Okay. Multiply by 180, divide by pi. It's 22.5 degrees. Is that between the two numbers it has to be? Yeah. So the answer to this is yes. So 22.5 degrees is between negative 90 and 90. All right. How about this one? Same formula. Inverse is on the outside, regular is on the inside. Does anybody remember what 3 pi over 2 is? We use that one a lot on the unit circle.
Negative 90 degrees.
Yep, it is negative 90, which is the same as 270. Okay, and I'm going to write it as 270 because this is positive. Okay, that's positive 270. Is positive 270 between these two numbers? No. So this one, if you were to type that in, you would not get back the same answer. This is too big. Okay, it's 270. This one? Well, if it was going to be negative 90, I'd have to write it like this. That's negative 90. They are equal on the unit circle. They're coterminal. But don't add or subtract 360 from these. That'll definitely mess us up. Yeah, just look at it the way it is. Okay, this one. Inverse sine is on the inside. Is that 2a or 2b? It's 2b. So now we got to be between negative 1 and 1. Okay, is my argument, that's this number right here, between negative 1 and 1? Nope. That would not work. Okay, and the last one, same type, inverse on the inside, 0.6. Would that work?
Yes.
Yeah, what do we got to be between? Negative 1 and 1. 0.6 is right, a little bit less than 1. So yes, that would work fine. Okay, any questions on those two formulas? Okay, you don't have to know which one is 2a and which one's 2b. Those are just the names that your book uses. Okay, you just have to know the two formulas. Okay, and you can make a reference sheet for this test. Right, for cosine, basically the same idea. Okay, when the inverse is on the outside and regular is on the inside, does anyone remember what degrees did we have to be between yesterday?
0 and 180.
0 and 180. Yeah. Okay, so 0 to 180 if you go in degrees.
Bless you.
Bless you.
Thanks.
0 to pi in radians. Okay, and it's the same idea. You could try this on your own. Type in inverse cosine of cosine. Pick a number between 0 and 180 and it'll work. Pick a number higher than 180. Try 200. You'll get a different answer back. It won't work. Okay, and 4b. Same idea as formula 2b. Bless you. Inverse is on the inside. Okay, regular one's on the outside. Okay, the restriction here is going to be how high and low cosine goes. Okay, so let's graph that. What's the highest and lowest it looks like cosine goes? 1 and the lowest? Yeah, it's 1 and negative 1 again. Okay, cosine and sine are almost the same function. In fact, the only difference between them is kind of where they start. If you took the one in blue and just moved it to the right a little bit, that would become the same thing. Or take the one in red and just push it to the left. It'd be the same thing. Okay. All right, so let's just try Try a couple. All right, that first one. Look where the inverse is. Okay, match it up with the formula. Look at your number. And then look if it's between what it has to be. John, what do you think? Is this going to work, or will this not work?
Yeah, it'll work.
Yeah, this is 4b. Got to be between -1 and 1. This one works fine. Okay, and let's try this one. Now we're switching it. Put the inverse on the outside. Put the regular one inside. Okay, when the inverse is on the outside, you got to be between 0 and 180. Okay, so Dakota, is that one going to work?
No.
No, 210. It's not between 0 and 180. Okay, questions on that one? Okay, so that's cosine. And the last one, what's our last trig function we have a button for? Yep, inverse tangent. Okay, same idea as the other two. Then, what did we have to be between for angles on tangent, inverse tangent yesterday?
-99.
And what's different between that and sine? Because sine is also -90 to 90.
There was no equal to.
Yeah.
Less than.
Perfect. No equal to's. Okay, so formula 6a, inverse tangent, regular tangent, cancel each other out. And the answer that you're going to get is whatever is right there, as long as that's a number between -90 and 90. Okay, when we switch it, put the inverse on the inside. Does anybody remember how high and low tangent went?
It's like a weird line.
Yeah, that one looked a little different, right? That's not a nice wave, okay, like the other two. How high and low does this one go?
Forever.
Yeah, it goes up forever and it goes down forever. We can't see it because it's going off the screen. Okay, but this curve just keeps going up. Yeah, I can show you. If I let x be 89, y is up at 57. It's way off the screen. Okay, as I get very close to 90, y starts to get huge. Okay, it's up at 5,000. So it goes up forever, goes down forever. So basically, this formula works all the time. Okay, so with 6b, you don't really have a restriction. All right, so how about this one? Tangent of inverse tangent of 30.4. Is that going to work? Will that give me 30.4 if I type it in?
Yes.
Yeah, that'll work fine. This is 6b. There's no restriction. And if you get stuck, you could always just type it in. Tangent, inverse tangent, 30.4. 30.4. So it works. Okay, so you're going to see some problems like that in the homework and on the test. The only thing I could do a little different is I could say this. I could say simplify and erase that. If I do this, don't write yes. Okay, the answer to that is not yes. What's the answer to this now? 30.4. I'm going to do one like that on the test, and a lot of people write yes as the answer. Right? But if it says simplify, you can't put yes. You got to simplify it. Okay. Put it back the way it was. What's that? What if it's a no? If it's a no, then you'd write cannot be simplified. Yep. So if it's one of the ones that doesn't work, you'd write cannot be simplified. All right. So that's that's pretty much it for section 3.1. All right, so the rest of the week, we're going to do right triangle trig. Kind of the big goal when you're doing right triangle trig is you're going to be given a triangle. You'll be given a little bit of information about it, and you're going to have to find out everything else about it. Okay? Things you have to find out about triangles: how long are the sides? How big are the angles? So there's 6 things you have to find: 3 sides, 3 angles. And you're always going to be given some stuff to start. First, just review a few terms about right triangles. A right triangle is any triangle that has a 90-degree angle. The side across from the 90-degree angle, that's the hypotenuse, okay, or the longer side. The 2 shorter sides, those are your legs. Next thing is an acute angle. What's an acute angle? It has to be a certain size. Actually, between 2 things. Yeah? Less than 90, but also more than what? Yeah, it can't be negative. Okay? It has to be more than 0. So negative 20 degrees, that's not acute. All right, so an acute angle, it's less than 90, but greater than 0. All right, Pythagorean theorem. Okay, so it's a theorem you've probably seen a lot: geometry, algebra 2. And what does this theorem have to do with? I mean, it's with right triangles, but does it have to do with the angles or the sides? Yeah, it has to do with the sides. Okay. Anybody tell me what is the Pythagorean theorem? And if you use all letters to explain it, I'm going to ask you what those letters mean. What is the Pythagorean theorem? Okay, so a squared plus b squared equals c squared. And what's an a, b, and c?
A and B are the legs, I believe.
Yep, a and b are the legs,
C is the hypotenuse.
and c is the hypotenuse. Okay, so the idea of the Pythagorean theorem, if you take one leg and square it, take another leg and square it, add them up, that's equal to the hypotenuse squared. You can call them a, b, and c. You can call them x, y, z. Call them whatever you want. Most people use a, b, and c. Okay. One other thing we should probably keep in mind about a triangle has to do with the angles. Does anybody know a fact about all the angles in a triangle? There's 3 of them, but how about another fact? Yep. They all add up to 180. Right? What that means is if you know 2 angles, you automatically know the third one. Okay? So keep that in mind too. All the angles add up to 180. Okay. Everyone got the Pythagorean theorem? All right, so what we're going to do, just like we did with unit circle trig, we're going to redefine the 6 trig functions. We're going to have sine, cosine, tangent, secant, cosecant, cotangent. Except we're not going to do them on a unit circle. We're going to do them in a triangle. And we're going to use the words opposite and adjacent and hypotenuse. But I need to make sure people understand what opposite means and what adjacent means. Okay, so opposite, okay, one way to think of it, it's the side that's farthest away from the angle. Okay, it's the side that's across from it. Okay, opposite. Okay, or another way to think of it, if this is the angle being referenced, okay, there's 2 angles, I have to tell you basically which one we're referencing. I'm referencing the one at the bottom. Opposite is the side that if I got rid of it, it has nothing to do with this angle. This side doesn't even touch this angle. It's across from it. Okay, that's opposite. Okay, adjacent is the side that's right next to the angle. That's not the hypotenuse. Right? So it's the side in the triangle that forms part of that angle. If I took away that bottom side, I wouldn't have an angle anymore here. Okay? So this is adjacent. That side is opposite. All right, now let's say, what if I did this? What if I said, okay, we're going to reference the angle up here now. What would happen to opposite and adjacent? They would switch. Okay, if you put the angle at the top, opposite is the side that's farthest away, the side that has nothing to do with the angle. That's opposite. Adjacent is the side that's right next to the angle. That's not the hypotenuse. This is adjacent. Right, so opposite and adjacent are what we call relative terms. Okay? The easiest way to explain that is they're like left and right. Left and right changes depending on which way you face. Right? So for me, if I'm facing you, the windows are right, the door is left. But for you facing me, the door is right and the windows are left. Okay? It's just the opposite. All right? So these are relative terms. They change depending on where you're standing. And the way I like to think of where you're standing is where you put theta. Are you standing at the top or are you standing over here? Okay. Depending on where you stand, changes opposite and adjacent. Questions on that? Scroll down. All right, so now that we understand what the hypotenuse is, okay, that's the side across from the 90. What opposite is, that's the side that's farthest away from the angle, and adjacent is the side right next to the angle. We can redefine all 6 trig functions using these 3 terms: opposite, adjacent, hypotenuse. Okay, everybody have what's on the left? So theta, that represents an angle in a right triangle. Okay, and the sine is found by taking the length of the opposite side and dividing by the length of the hypotenuse. Okay, the cosine, you find that by taking the length of the adjacent side and dividing by the hypotenuse. And tangent, take the length of the opposite side, divide by adjacent. Okay, and there's a trick to remembering these. Does anybody know the trick? It's a word you can use. Yeah?
SOHCAHTOA.
Yeah. Can you just explain that?
S for sine and OH, which is opposite hypotenuse.
Right, so we have sine is opposite over hypotenuse. Yep.
And then co, which is the cosine A for adjacent and H for hypotenuse.
Yep. And we have cosine is adjacent over hypotenuse.
And TOA for tangent, which is opposite and adjacent.
Yeah. And tangent is opposite over adjacent. SOHCAHTOA. So if that helps, you can use that. Somebody before once said Sacagawea. That won't help, but you can try it. SOHCAHTOA, not Sacagawea. And now, if you know those 3, and you remember what we did for unit circles, it's very easy to get the other 3. What do we do with each one of these? Yeah, we just flip them. Okay, so your cosecant is hypotenuse over opposite. Your secant is hypotenuse over adjacent. And your cotangent is adjacent over opposite. Okay, you just flip them. Yeah, Choshikawa. So if you can do the other three and you get Choshikawa. I like Sakatoa better. That doesn't really work. All right. Any questions on those 6 definitions? All right, so let me show you what kind of problem they're going to ask about. All right, so they'll give you a triangle. They'll give you 2 sides. They'll tell you where you're standing. Okay, that's basically where they put theta. And they want to know all 6 trig functions. Okay, now before I can even find all these trig functions, there's something missing here. The hypotenuse. Yeah. How do I get that? Yeah, just use the Pythagorean theorem. And does anybody know what it's going to come out to? 5. 3 squared plus 4 squared equals, call it c squared. That's 9 plus 16. Gives me 25. Take the square root, get 5. Okay, this is called a Pythagorean triple. When all the sides of your triangle come out without decimals. 3, 4, 5. Another one is 5, 12, 13. There's millions of them, but this is a common one. All right, so now we can fill in all 6 trig functions. Chris, what's our definition for sine? What over what?
Opposite over hypotenuse.
Opposite over hypotenuse, yeah. What's opposite theta here? 4, hypotenuse? 5. That's it. So the sine is 4/5. Okay, Alex, how about my cosine?
Adjacent over hypotenuse.
Nice. Adjacent over hypotenuse, which in this case would be what 2 numbers?
It also be 4 over 5.
Well, what side is next to theta? This is the side that's opposite theta.
3 over 5.
Yeah, 3 over 5. Questions on that one? And Derek, how about tangent? What's the definition of tangent?
That's opposite over adjacent.
Yep, good. Opposite over adjacent. And what's opposite theta?
4, right?
4, yep. And what side is right next to theta? That's not the hypotenuse.
No. The theta. Yeah. 3.
3.
Yeah.
All right. Now, once we get sine, cosine, and tangent, Nathan, what do I do with all 3 of these to get the next 3?
You just flip them.
Just flip them. Here's your cosecant, 5/4. Secant, 5/3. And cotangent, 3/4. Okay, as always, if this number doesn't come out nice, if it's a square root, you could get square roots in the bottom of fractions, and we do need to fix that. Okay, but I picked nice numbers for this one.
Do you have any of the square roots on that?
There will be some square roots on the homework. Yeah. Questions on those? All right. Just like we did on the last test, this would be 6 separate problems. Okay, I'm not going to ask you to do all 6 in the same problem. All right. And complementary angles. Okay. What are complementary angles? Yep.
2 angles that add up to 90.
Yeah, the 2 angles that add up to 90. Okay, and what I'm saying is that if you draw any right triangle, doesn't matter how you draw it, I'm saying that the 2 acute angles, this one and this one, always add up to 90. How come? Okay, all the angles do add up to 180. So why do these 2 checked off have to add up to 90? Yeah, I already used 90 for the right angle. Okay? If they're all going to add up to 180, that only leaves 90 left for the other 2. Okay? So the other 2 angles in a right triangle are always complementary. They always add up to 90. So hang on to that thought for a minute, okay? Complementary angles. I'm going to come back to it. We're going to combine it with this idea of what's called cofunctions. Okay? Cofunctions are basically when you take a trig function and you put the word co in front of it. Okay? It's a different way to pair trig functions up. We usually pair them up like this. Sine, cosecant, cosine, secant, tangent, cotangent. Okay? When you pair them like that, these are called reciprocals. You flip one to get the other. Okay? These are called cofunctions. Sine, cosine. Secant, cosecant. And the last one just happens to be the same. Tangent, cotangent. Okay? These are your three pairs of cofunctions. Sine with cosine, secant with cosecant, tangent with cotangent. Okay. Any questions on if I gave you a function and said, what's the cofunction of it, how you'd find it? So if I said, Paige, what's the cofunction for secant? Cosecant. Callie, what if I said, what's the cofunction for cosine? Sine. Yeah, we wouldn't say cosine. We'd just say sine. Sine, cosine, and so on. All right. On your paper, I want you to draw that triangle. Okay, the hypotenuse would be side C, but I'm not going to use it here. I won't need C. I've labeled the height as A, the base is B. And then I've got two Greek letters. Okay, usually when we're solving a triangle, they use Greek letters. Just like in algebra, they use X and Y a lot. We use alpha and beta a lot. And that's what these two letters are called. This symbol right here, that's alpha. That's how you write it. That's how you pronounce it, alpha. This is beta. Okay. One thing when we draw it, you always have to keep A opposite alpha. A is always opposite alpha. B is always opposite beta. Okay, you always have to draw it that way. Okay, if you want to have your triangle face a different way, that's fine. Just keep A always across from alpha. Keep B always across from beta. Always set it up like that. All right. And what do we know about alpha and beta? If you add them up, what would they add up to? Yeah, they'd have to add up to 90, which means they're complementary. Okay? So keep that in mind. Let's find the sine of alpha. Okay, so sine is opposite. Actually, you know what? We're going to need to label that C. Opposite over hypotenuse. Andy, what's the side that's opposite alpha? A. And what's my hypotenuse? C. That's the sine of alpha. A over C. Let's find the cosine of beta. Okay, watch what happens here. Cosine of beta. Jacob, what's cosine? What two sides do we use?
Opposite and hypotenuse.
That's sine. We use opposite and hypotenuse. Derek? Oh, yeah. Yeah, adjacent and hypotenuse. Yep. And Derek, what side is adjacent to beta? What side is right next to it? A. Yep. And you said adjacent over hypotenuse. What side is across from the 90?
C.
C. Yeah, what do you notice Anybody, about the sine of alpha and the cosine of beta? They came out the same. Okay, let's try one more. Let's do tangent of alpha. Okay, so tangent is opposite over adjacent. Analia, what side is opposite here? Alpha.
A.
A. And what side is adjacent to alpha?
B.
B. Okay, so tangent of alpha is A over B. Now instead of tangent, let's find the cotangent. And instead of alpha, let's use beta. Okay, cotangent is adjacent over opposite. Okay, Lauren, what side is adjacent to beta? A, yep. And what side is opposite beta? B. Notice it came out the same again. What are these two things called? Sine and cosine? Or tangent and cotangent? Yep, cofunctions. And these two angles are what? Because they add up to 90. Complementary. Okay, so this is the complementary angle theorem. Okay, and very simply, this is all it says. If you take cofunctions, like we just were, and you take angles that are complementary, the answers always come out the same. Okay, so cofunctions of complementary angles come out equal. Right, so let's see if we can figure out just a couple numerically. I've got sine, and I've got 30 degrees. What's the cofunction for sine? Cosine. Okay, that's the cofunction. And what's the complement of 30? 60. Those two things are exactly the same.
How'd you do that? How'd you get that?
So look at your first trig function, it's sine. And go back to your list and find out what's the cofunction of sine. Cosine. Okay. Next thing is I'm looking at this number. Okay. Trying to find what number would I add to that to get 90.
Oh.
60. Okay. Let's just check it. Take the sine of 30, 0.5. Cosine of 60, 0.5. They come out exactly the same because they're cofunctions. And these angles add up to 90. Okay, next one. How about for tangent? What's the cofunction for tangent? Yep, cotangent. And what's the complement of 15? 75. So the tangent of 15 and the cotangent of 75 are exactly the same. These are cofunctions. These are complements. Okay, and how about the last one? Anyone think they could tell me what the secant of 40 would be the same as? John?
Cosecant at 50 degrees.
Yeah. The secant would be cosecant. And what'd you say for the angle?
50 degrees.
Yeah. What's the complement of 40? 50. Yeah. So now I want to use that idea to simplify this. I've got the sine of 15, negative sine 15, divided by cosine 75. Okay, this problem is set up very special. Okay. What are sine and cosine? Yep, those are cofunctions. What's 15 and 75? Those are what? Those are complementary angles. So what does that mean? Sine of 15 and cosine of 75. These two things are the same. This and that are the same thing. So if you divide them with a negative in front, what would you get? -1. Okay? Anytime you divide two things that are the same, you get 1. If you put a negative in front, it becomes a negative. Right? I have no idea what the sine of 15 is. Some decimal. I really have no idea. The cosine of 75. Okay? That's also some decimal. I have no idea. But what I do know is they're the same. So all I know is if I divide two things that are the same, I get 1. If I stick a negative in front, I get negative 1. Okay? If you changed 15 to 14, this whole problem's out the window. Can't do it. Then you'd have to use a calculator. Okay? These have to be cofunctions. These have to add to 90.
Wait, if you divide by the same, it's
If you divide two things that are the same, you always get 1. Think of like 2 divided by 2. You get 1. How about this one? Tangent 12 minus cotangent 78.
90.
Think someone said it? 0. Why? Yeah, they're the same. Tangent, cotangent, those are cofunctions. 12 and 78 are complementary. I have no idea what the tangent of 12 is. I have no idea what cotangent 78 is. But I know they're the same. Anytime you subtract two things that are the same, like 2 minus 2, 3 minus 3, you get 0. All right, so this trick works with subtraction, works with division. What about addition? If you add two numbers that are the same, do you always get the same answer? You think then?
You wouldn't get the same answer, you get double, right?
Yeah, you get, so if you do 5 plus 5, it's not the same as 6 plus 6. Although 5 minus 5 and 6 minus 6 are the same. It doesn't work with addition. You get the answer doubled. How about multiplication? If you multiply two numbers that are the same, do you get the same answer all the time? No, you get the number squared. 2 times 2 is not the same as 3 times 3. But 2 divided by 2, 3 divided by 3, those are the same. All right, so this trick only works with division and subtraction. Any questions on that? All right, so give you guys a little bit of time to start the homework. Okay, first part, this is all yes or no. All you have to do is write yes or no for every problem. Okay, that's 187, 46 to 51, and 53 to 55 all. And then the second part, this is right triangle, the beginning of right triangle triangle. Page 255, 9 to 21 odd. Okay, so you do have about 20 minutes. Okay, so please try to get started on that, and I will walk around and help you out.